Hi, in this short video, let's discuss square numbers very briefly. So remember we introduced exponential notation. Suppose a is a number and n is a positive integer. We said a to the n is a shorthand notation for a long expression, which is just the number a multiplied by itself, and there's n copies of them. So a is multiplied by itself that many times. That's what a to the n stands for. So by that definition, if you ever see a number b, and here b is a number, b to the 2 or b raised to the 2, this when we have 2 in the exponent, it's a special case and we actually have a name for it. We rarely read this as b to the 2, we call it b squared. So remember that. And by this definition, b squared simply means the number b multiplied by b. And that's b squared comes from this. If you draw a square whose side lengths are b, and we know the area is b to the 2, and we like to call it b squared. It's associated with this picture of the area square and the area. So practice that. Instead of saying b to the 2, just say b squared when you see an exponent of 2. And remember, b is a number. And now I want to introduce you to square numbers of the positive integers. This sequence 1, 4, 9, 16, 25. I've written up to 100, but you could keep on going. Those are square numbers. Let's see. Why is 1 is square numbers? 1 is 1 squared. 4 is 2 squared. 2 times 2 is 4. Similarly, 9 is a square number because 9 is 3, a positive integer, squared. 3 times 3 is 9. So similarly, you can work them through and try to do this exercise many times. So you can just look at these numbers if you come across them and think, oh, that's a square number. So if you see 64, I want you to think, oh, 64 is a square number, it's 8 squared. Or 25 is a square number, it's 5 squared, and so on. I want you to develop that relationship with square numbers. It will come handy in another video on another math topic. Thank you.